Good morning students. In the previous class we have discussed few problems from exercise 3.5 and in today's class we are going to do the remaining sums from the same exercise. Okay, look into the sixth question. Find all prime factors of 1729 and arrange them in ascending order. Now state the relation, if any, between two consecutive prime numbers. Okay, so the first thing what we have to do is we have to prime factorize 1729. Okay, so let us start doing 1729. Okay, so how will you prime factorize it? This number does not end with an even number, so we cannot factorize it with 2. It is ending with 9, but will 1729 come in 3 table? Just check it. 17 is given here, 3 5s are 15, 2 will be remaining, so 22, and 7s are 21, 1 will be remaining, 19 is coming here. So 19 will not come in 3 table, right? So then you can check it in 7 table. Okay, so 7 2s are 14, 3 will be remaining 32, 7 4s are 28, again 4 will be remaining 49. Yes, it will come in 7 table. Okay, so write 7s are, okay, 2s are 14, 3 is remaining, so here you will join this 3 with this 2, so you will get 32, and the 4s are 28, again 4 will be remaining, you will get 49, so 7 7s are 49. Is it clear? Then again this number is not divisible by 3 and it is not divisible by 7 also. Will it come in 9 table? Just check it. 9 ones are 9, 9 twos are 18, and 6 is remaining, but 67 will not come in 9 table. Okay, now let us check in 13 table. Okay, 13 ones are 13, so here what is remaining then? 11 is remaining, and 13 nines are 117. So you will have 13 ones are 13, you will again 11 will be remaining, so 13 19s are 247. Okay, so here 19 is again a prime number, simply you will have like this. Okay, so now you can write 1729 as 7 into 13 into 19. Is it clear? Okay, now what is the question? State the relation, if any, between two consecutive prime numbers. Okay, so now see the consecutive prime number. 7 is the first prime number. The next bigger number is 13 and the biggest number is 19. So what is the relation between all these three? What is the difference between 7 and 13? It is 6. Again 13 and 19, the difference is 6. Okay, so the relation is nothing but the difference between the two consecutive prime numbers is 6. Okay, here the difference between two consecutive prime numbers is 6. So this is the relation for this prime factorization. Is it clear? Now let us look into the seventh question. What is the question given here? The product of three consecutive numbers is always divisible by 6. Verify the statement with the help of some examples. Let us take three consecutive numbers. What do you mean by consecutive numbers? The adjacent numbers are known as consecutive numbers. Okay. So let me take 2, 3 and 4. Okay. So what is the product of 2, 3 and 4? Product is nothing but multiplication, right? So 2 into 3 into 4. So what is 2 into 3 into 4? 2 3s are 6 and 6 4s are 24. Okay. Is 24 divisible by 6 or not? Yes, it is divisible. It is divisible by 6, right? Because 6 4s are 24. 24 is divisible by 6. Hence, the statement is verified. Okay. When any three numbers are taken in consecutive manner, the product of all the three numbers is always divisible by 6. Next sum that we are going to see is 10th one. What is the question? Determine if 25,110 is divisible by 45. Okay. So how can you split 45? 45 is the product of 9 and 5, right? But 9 and 5 are co-prime numbers. Yes or no? In the second property, we saw that when any two numbers are given as co-prime numbers and some other number is divisible by both the numbers, then the number is divisible by their product also. Okay, so now in this question it is enough to prove that 25,110 is divisible by 9 and it is also divisible by 5. If it is divisible by 9 and 5 both, then it is compulsorily it is divisible by 45. Okay, so now let us do it. Let us check the divisibility of 25,110 by 9 and 5. Let us first check it with 5. Divisibility by 5. So how to check it divisibility by 5? If any number is divisible by 5, it should be ending with 0 or 5. So here this number ends with 0, so pakka it is divisible by 5. Okay, so you will write 25,110 ends with 0, therefore it is divisible by 5, right? Next, let us check the divisibility by 9. Okay, so how to check the divisibility by 9? Do you remember it? Yes, divisibility by 9, we have to add all the digits and we have to find the sum. If the sum is divisible by 9, then the whole number is divisible by 9. Is it clear? So let us find the sum first. 2 plus 5 plus 1 plus 1 plus 0. So what is the sum here? 2 plus 5 is 7, 7 plus 1 is 8, 8 plus 1 is 9. Is it clear? Okay. So we know that 9 is divisible by 9, right? Therefore 25,110 is also divisible by 9. Is it clear? Since it is divisible by both 5 and 9, it is surely divisible by 45 also. Okay. Hence, 25,110 is surely divisible by 45. Why 45? Because it is 9 5s are. Is it clear? 9 and 5 are co-prime numbers. So any number which is divisible by both 9 and 5 will be divisible by its product also, that is 45. The next question that we are going to see is 11th question. Here the question is 18 is divisible by 2 and 3. It is also divisible by 2 into 3, that is 6. Similarly, a number is divisible by both 4 and 6. Can we say that the number must also be divisible by 4 into 6, that is 24? If not, give an example to justify your answer. So this is the question. Here it is given 2 3s are 6, right? If any number is divisible by 2 and 3, it must be also be divisible by 6 because 2 and 3 are prime numbers, co-prime numbers. Okay, they don't have any common factor other than 1. But look at 4 and 6. 4 and 6 are not co-prime numbers. They have more than one factor as common factor. Okay. So let us take an example. So this statement is wrong actually. If not, give an example to justify your answer. So we are taking an example. Let us take 12. Okay, 12 is divisible by 4 or not? Yes. 12 is divisible by 6 or not? Yes. But 12 is not divisible by 24. Is it clear? Now let me tell you. Look here. 12 is divisible by 4 or not? Yes. 12 is divisible by 6 or not? Yes. But 12 is not divisible by 24. This does not exist. Okay. Is it clear? So divisible by any two non-co-prime numbers, then it cannot be divisible by its product. So is it clear? Here, no. The number is not divisible by the product. Is it clear?